Hello everyone, welcome to lesson 9-1, Probability of Simple Events. When working with probability, we have to answer the question, how can you predict the outcome of future events? And for vocabulary, we will look at probability, outcome, simple event, random, and complementary events. Vocabulary startup. Probability is the chance that some event will occur. A simple event is one outcome or a collection of outcomes. What is an outcome? Well, math definition for a probability is as simple, the math definition for the word outcome is a possible result in a probability experiment. Okay, so it's a possible result. A real world definition of an outcome, we could say, is the result or product of an event, the solution. So this is how we understand the word outcome. It's often the solution or the result of an event. Real world connection. For a sledding trip, you randomly select one of the four hats shown: green hat, blue hat, purple hat, red hat. Complete the table to show the possible outcomes. So in the first outcome, you chose the green hat. That means there's a possibility you could choose the green hat again, but all four hats have equal probability. So in outcome 2, you could choose the blue hat, outcome 3, the purple hat, and outcome 4, the red hat. Write a ratio that compares the number of blue hats to the total number of hats. Well, we see that we have one blue hat, correct? So I'm going to write one blue to how many hats in total? To 4 hats in total. So for every 4 hats, there will be one blue one. Describe a hat display in which you would have a better chance of selecting a red hat. Well, if let's say the purple one were red and these two were red, then the probability would be 2 hats are red to 4 hats in total, which simplified means 1 hat for every 2 hats will be red. So then what is probability? We just wrote ratios. Probability are ratios where the probability of an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes. So favorable outcomes likely to have an outcome of, or the favorable meaning the actual outcomes that you did get compared to all the number of outcomes. So you can see here the probability, and then you put in parentheses what event you're talking about: the probability of getting an A, or the probability of choosing the green hat. Number of favorable outcomes, well, there was only one green hat, so you would put a 1 there. To number of possible outcomes, there were 4 different hats, right? So you would have 1 over 4. Now, if we were to break down this scale of probability from 0 to 1, or you could say percentage, right? 0 to 100%, right? Where we have 1/4, a half, a third. If we were to break it down from 0 to 1, we would add vocabulary to go along with it. Impossible would be 0%. Impossible. Unlikely, maybe a quarter. As likely to happen as not, or 50-50. We have half. Likely, 75%, or 3/4 of the way. Now in between, you could have very likely, okay? You could have very unlikely, extremely unlikely, or extremely likely on this side. The probability of a chance event is a number between 0 and 1 that expresses the likelihood of the event occurring. Greater numbers indicate greater likelihood. A probability near 0 indicates an unlikely event. A probability around a half indicates an event that is neither unlikely nor likely. And a probability near 1 indicates a likely event. Near the 1, near the whole, right? The whole, which would be 100%. Probability can be written as a fraction, decimal, or percent. So here we have it written as a fraction. You see that? We can also convert those fractions to decimals, and those decimals easily converted to percent. When would an outcome be random? Well, when they have equally likely to occur. So outcomes occur at random if each outcome is equally likely to occur, like the hats, 1 out of 4, and there were 4 different kinds of hat. But if there would have been 2 red hats, then it's not equally likely. The red has a more likelihood. Now let's explore how the ratios can be written. And here's an example. There are 6 equally likely outcomes if a number cube, like a dice, with 6 sides labeled 1 through 6 is rolled. You see it here, right? There's 6 sides, and each number has 1 out of 6 chances, correct? There is only 1 6 on the number cube. That's right. There's only one of them. So there's a chance of 1 out of 6 for it to land. So here we have the probability for the number 6 is the number of favorable outcomes, which is only 1 because there's only one chance, out of all the numbers, out of all the possible outcomes, number of possible outcomes. So that's 6. There's only 1 6 in the entire dice, and there are 6 numbers there. So there's only 1 chance out of 6 chances that it will land on a 6. The probability of rolling a 6 is 1/6, or about 17%, or about 0.17 of a chance. Okay, now let's try the practice. A coin is tossed, and here's a coin. You see a coin has 2 sides. It has the heads and the tails, right? That's what we call it, heads and tails. Find the probability of the coin landing on heads. Write your answer as a fraction, percent, and as a decimal. So here we have 1 side out of 2 sides, and this is only counts for 1 side. So what is the likelihood? Well, it looks like we have 1 side for 2 sides, which would equal 0.5 as a decimal and 50%, okay, as a percentage. Now, how did they get that 50%? Decimals always have to be multiplied by 100 to turn to 50%. It's a half. So this is the most basic we can get. Make sure that when you write this down, you include an image of a coin, or at least you write down the explanation that this is a coin. A coin, or write a sentence, a coin has, okay, a 50% chance of landing on heads. Example number 2. Find the probability of rolling a 2, 3, or 4 on the number cube. So if you have a dice or a die, what are the probabilities that you roll a 2, 3, or 4? Now remember, there's only 6 numbers on a die, and here's 3 of them already. So that's half the numbers, right? The word or indicates that the number of favorable outcomes need to include the numbers 2, 3, and 4. So here's the word, okay, the probability for 2, 3, or 4, the number of favorable outcomes. So how many times could we get that number? Well, 3 times, right? Because there's 3 of them. Out of the total number of possible outcomes, well, there's only 6 numbers in the dice, so 3 over 6, and that would be half, right? When you simplify, because 3 is half of 6, 1 over 2. When simplified, so the probability of rolling a 2, 3, or 4 is half, 50%, or 0.5%. 4.5 as a decimal. Okay, now let's take a look at example. I believe this is example. It's still example 3, and we're just going to try it on our own now with this spinner. Okay, and for this spinner over here, looks like we have letters A to J. So it looks like we have 10 letters. Okay, the spinner at the right is spun once. Find the probability of each event. Write each answer as a fraction, percent, and decimal. Okay, so as we said, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. So all the probabilities will be out of 10, which makes it really easy to write it as a percent, correct? So what is the probability of F? Well, it's out of 10. So let's just write out of 10. And how many F's are there? There's only 1. So the probability of F, okay, probability of F is 1/10, which is the same as saying 0.1, and the same as saying 10%, right? Number 2. Now we're going to look at the probability for D or G. D or G. We have D or G, and there's only one of each, but this consists of 2. Now it's 2 letters out of 10 letters. So out of 10, probability for D and G is out of 10 is 2, right? When simplified, it's 1 out of 5. Right? When you simplify 2 over 10, it's 1 out of 5, which is 0.2. Remember how to write as a decimal? We just say the number as we see it when it's base 10, 2 tenths. So it's 2 in the 10th place, right? This is the units, the ones, 10th, and then 100th, 1000th, and so on. So 2 tenths, and to change that into a percent, we multiply by 100, which moves the decimal over 2 places to the left, and now we have 20%. Or simply, if you were to add a 0 here and a 0 here, right, you have your 20 per 100, 20%, 20 per 100. Okay, D. Okay, probability of a vowel. A vowel is A, E, I, O, U. Here's A, 1, E, 2, I, 3. So there's only 3 vowels out of 10. So probability of a vowel, I'm just going to put V for vowel, is 3 out of 10, which is 3 tenths, we just write it as 3 tenths, that's a decimal, sorry, comma, multiplied by 100 will make it 30%, 30 out of 100. Let's look at another key concept. Complementary events are 2 events in which either one or the other must happen, but they cannot happen at the same time. For example, a coin can either land on heads or not land on heads. The sum of the probability of the event and its complement is 1 or 100%. It's the total number of outcomes. So it can either happen or not happen, and those are complementary events. So for example, going back to the die, okay, rolling a dice. Find the probability of not rolling a 6 in example 1, not rolling a 6, okay? So the probability of not rolling a 6 and the probability of rolling a 6 are complementary because together the sum of the probabilities is 1, an entire probability, right? So probability of rolling a 6 plus the probability of not rolling a 6 equals 1. P6, probability 6, and probability of not 6 are complements. So they will give you the 100% option. So 1/6, it's probability of rolling a 6, remember? There's only 1/6 in all 6 options. And the probability of not rolling a 6, which is there's 5 other numbers, right? So there's a greater chance out of 6. When you add them together, it gives you your whole, right? So the probability of not rolling a 6, the probability of not rolling a 6 is 5/5, or about 83%. Okay, let's take a look at the probability of not finding something by identifying the complement. A bag contains 5 blue, 8 red, and 7 green marbles. So we have our 5 marbles plus 8 marbles plus 7 marbles equals 20 marbles, right? 8 plus 7 is 15 plus 5 is 20. A marble is selected at random. Find the probability the marble is not red. So we have to count the numbers that are not red. So we have 5 plus 7, okay, is 12. So we have 12 out of 20 marbles, which is the same as saying, we divide them both in half, 6 over 10, or 3 over 5, correct? So the probability of not choosing a red is, look at this number, this is 6/10, right? 6/10, so it's 0, it's the same as saying 0.6, or 6 in the 10th place, which is the same as saying 60%. So the probability that the marble will not be red is 60%. Okay, let's take a look at this real-world example. Mr. Harada surveyed his class and discovered that 30% of his students have blue eyes. So for every 10, 3 have blue eyes. Identify the complement of this event, then find its probability. Well, if 30% have blue eyes, that means 70% do not. right? The complement of having blue eyes is not having blue eyes, right? Not having them. It could be brown, green, whatever color, but of not having blue eyes, 70%. The sum of the probabilities has to be 100%, right? So probability of blue eyes plus probability of no blue eyes equals 100%. So probability is 30% plus probability of no blue eyes, which is, what's the difference between 30 and 100%? 70, right? It's our 70. So 30% plus 70% equals 100%. Okay, so the probability that a student does not have blue eyes is 70%. Thanks to the complement rule, we're able to identify that the other half needs to help us equal 100%. And that's how we solve for the not part, the information that's not being given. Okay, everybody, all we have left now is the guided practice. Make sure to leave this for class. Feel free to look ahead to see if you have any questions for class. See you then.